So first things first, you try substitution. You plug in the 8. So you get something that looks like that. Square root of 9 minus 3. You get 16 when you plug the 8 into 2x minus 16. And you get 0 over 0. 0 over 0 means you got to do more work. The more work in this case is multiplying by this thing called the conjugate. We take the radical expression, the part with the root, and I'm going to take that part exactly the way it is, the square root of x plus 1 minus 3, and I'm going to multiply by this thing called the conjugate. Oops. And so the conjugate in this case is the square root of x plus 1 plus 3. Remember, if you have a minus b, a plus b would be its conjugate. Something minus something, the conjugate is the same two items, but with the addition sign. In the denominator, we take the 2x minus 16, we just let that sit there, and we multiply by that same big conjugate expression. Because the only way I'm really allowed to change this problem is to make it look different but not change the value. So multiplying by a form of a what? Now, this was last Thursday, so I know it's been a while, so if we talk through the pieces. The two pieces that are not the conjugate relationship, they just sit next to each other. I don't do anything to them. I don't try to foil them together. I just let them sit there. 2x minus 16, square root, x plus 1 plus 3. The conjugates, I am going to multiply those. I'm going to FOIL those. First, outside, inside, last, multiplication. And the cool thing about a conjugate is when you multiply two conjugates, the same thing always happens. You end up with a, whatever the a was, but squared. So when you square the square root of x plus 1, you get x plus 1. Minus b squared. 3 times 3, or 9. You get that shortcut kind of answer. A plus b times a minus b. If you FOIL it all the way out, it looks something like this. And you end up with two pieces in the middle that add up to 0. And so a FOILing of conjugates always gives me the same kind of result. So this one's a little trickier because right off the bat you might be like, well, I don't see how this is going to work. Because I got x minus 8, I have 2x minus 16, I have conjugate stuff. I'm supposed to be able to see something that cancels, and I don't see anything immediately. But if you think about this little guy right here, if I change him into 2 times x minus 8, which would be a perfectly legal change, then I'll get a common factor to go away. And that's what has to happen for this conjugate method to work, is you have to, and that's why it will work this way if it's really a 0 over 0 problem. If it's a 0 over 0 problem using a root, a conjugate will give you this. You'll be able to see the problem written. So a common factor in the numerator and the denominator will divide away. In this case, it's the only thing in the numerator, so I gotta fill in the space with a 1. So this is going to end up at the limit as x approaches 8 of 1 over 2 times the square root of x plus 1 plus 3. So 1 times 2 times the square root of 9 plus 3. 1 over 2 times what's going to be 6. And so that final answer is 112. It takes a lot to go through these, for sure. Michelle, question? Okay, so the square root of 9, I kind of did 2 steps in my head. I did square root of 9 is the same as 3, and then 3 plus 3, yeah, I skipped a step. I didn't write it out. So square root of 9 is 3, and 3 plus 3 is 6. Good question, though. That's exactly the question you ask when you look at something like, I don't see where that came from. You can do these problems. I know you can do them. You just have to practice them. Yes? Up at the top? Up in the numerator or down in the denominator? Up in the numerator. Okay. So when I take this, oops, come on, give me a pen. Minus 3. Okay, when I take that and I multiply it by its conjugate, here's what happens. When I take this piece times this piece, the root of x plus 1 times the root of x plus 1 gives me x plus 1. Are you okay with that? Okay. And then, and this is the part I didn't show, so I'm lazy, when I go outsides, and I'll use green, my outsides are a 3 times the root of x plus 1. And then my insides are a minus 3 times the root of x plus 1. So firsts, outsides, insides, lasts. You all right with that? Okay. So then, see, look at this guy and this guy. They're exact opposites. So together, they make a 0. So all I have is x plus 1 plus 0 minus 9. So 1 plus 9, or 1 minus 9, excuse me, move negative 8. Okay, so yeah, that's kind of the weird thing that happens when you multiply 2 conjugates. It's really messy. It's like, oh my god, this is such a horrible multiplication problem, and it comes out in this really pretty answer. It's a really simple answer. Every time I multiply 2 conjugates, that's going to happen. I'm always going to end up with just the first, the A term, the first piece squared minus the second piece squared. Oops, where's my cursor? There it is. Okay, so then, so yeah, I didn't show all that. So all of this turned into x minus 8. My 2x minus 16 I wrote as 2 times x minus 8, and then my x minus 8 could go. Okay. I think that, I'm going to stop